Good morning, everyone. In this episode, we are going to discuss differentiability. These are all the synopsis. We are going to discuss differentiation by chain rule, implicit function, ITF, inverse trigonometric functions, exponential functions and logarithmic functions, differentiation by parametric form, second order derivative and Rolle's theorem and LMVT, Lagrange's mean value theorem. Very important theorem, Rolle's theorem and Lagrange's mean value theorem. These are all the synopsis we are going to discuss in differentiability. In this episode, few topics we are going to discuss. Out of these, 1 or 2, 3 concepts we are going to discuss in this session. Before entering to this episode, I suggest to understand, to by heart, the differentiation of all the trigonometric functions and general functions what we have learned in first PU or 11th standard. Is it clear? One more time we are going to discuss all the differentiation part, differentiation of sine, differentiation of cos, differentiation of tan, differentiation of e power x, differentiation of log x. Again, once at a glance we will see. So to better understand the concept of differentiability, I suggest to by heart all the differentiation formulas. More differentiation formulas we are going to learn in this chapter differentiability, that is inverse trigonometric, that is sine inverse x, differentiation of sine inverse, differentiation of cos inverse, differentiation of tan inverse. Okay, so to better understand by heart what you have studied in first PU or 11th standard differentiation. Thank you. I have told you that first PU or 11th topic, basic differentiations. What are all we have studied already we know. Let us discuss all those concepts. Differentiation of constant, that is nothing but 0. Differentiation of 5, differentiation of 6, differentiation of any constant is 0. Derivative of x power n into x to the power n minus 1. Yes or no? Derivative of x power n is n into x to the power n minus 1. Derivative of e power x itself. Derivative of log x 1 by x. Derivative of root x 1 by 2 root x. Yes or no? Derivative of root x 1 by 2 root x. Now derivative of 1 by x minus 1 by x square. Derivative of 1 by x is minus 1 by x square. Derivative of a power x log a. A power x log a, where a not equal to 0. This condition is very important. A not equal to 0. Now we will enter into the trigonometric ratios. So derivative of sin x cos x. Derivative of cos x minus sin x. Derivative of tan x sec square x or sec square x or sec square x. Derivative of cosec x minus cosec x cot x. Minus cosec x cot x. Derivative of sec x tan x. Sec x tan x. Derivative of cot x minus cosec square x. See, if it is c, cos x means c. If it is c, minus will come. See, cot x minus cosec x minus is there. This is the way you have to. Already you know these trigonometric ratios, differentiation you know. Some more differentiation we are going to learn in this chapter. Inverse trigonometry, that means differentiation of sine inverse x, differentiation of cos inverse x, the differentiation of tan inverse x and its reciprocal. The cosec inverse x, sec inverse x and cot inverse x. Okay, so differentiation of constant 0, differentiation of x power n into x to the power n minus 1, differentiation of e power x is e power x, differentiation of root x is 1 by 2 root x, differentiation of 1 by x is minus 1 by x square. Now differentiation of a power x is a power x log a, where a is not equal to 0, differentiation of sin x cos x, derivative of cos x minus sin x, derivative of tan x sec square x, derivative of cosec x minus cosec x cot x, derivative of sec x tan x, derivative of cot x minus cosec square x. These are all the basic differentiation you should know before entering to this chapter. Is it clear? So let us move on to this episode, that is function of a function rule or chain rule. The The first topic in this chapter is function of a function rule or chain rule, how to differentiate. Okay, let us. Okay, function of a function rule or chain rule. Let us consider y is equal to f of u or f of x. You consider y is equal to f of x. How to differentiate this y with respect to x if the function is a chain rule? Dy by dx is equal to dy by du into du by dx. Once if I do example, you will understand the concept of chain rule. Let us move on to the example. So y is equal to sine of x square. So first find dy by dx. Find dy by dx. Y is equal to sine of x square. Find dy by dx. Listen here. We have two functions over here. First function is sine and second function is x square. We have two functions here. One is sine, another one is x square. Yes or no? So for time being, I am going to consider y is equal to sine of u. I am going to consider. That means u is equal to x square. U is equal to x square. I have to differentiate with respect to x. That means du by dx. Yes or no? I am considering u is equal to x square and again differentiating with respect to x, that is du by dx. Yes or no? Du by dx is what? 2x, because x to the power n is n into x to the power n minus 1. N into x to the power n minus 1. Using this concept, I can write du by dx is 2x. So du by dx over. Now next sine u. What is dy by du? Dy by du. Derivative of sine is what? Cos. So cos u. Yes or no? Therefore, dy by dx is equal to dy by du into du by dx. Dy by du is what? Cos u into what is du by dx? 2x. I have to replace this u because I am considering u as 2x. Okay? So that is cos of x square into 2x. So dy by dx is nothing but cos x square 2x. Is it clear? So this is the function of a function rule or chain rule. One more example we will see. So next example is y is equal to tan of 2x plus 3. Tan of 2x plus 3. See, here we have an algebraic function. Here one is a trigonometric function. So trigonometric and algebraic functions. So both functions are there. So for that I am going to consider y is equal to tan u. So what is u over here? 2x plus 3. 2x plus 3. What is du by dx? Du by dx is nothing but you have to differentiate this as well as differentiate 3. Differentiation constant is 0, that is ruled out. So differentiation of 2x. What is differentiation of 2x? That means 2 into differentiation of x is nothing but 1. So differentiation of 2x is nothing but 2. Is it clear? So du by dx over there is 2. Now dy by du. Dy by du. What about tan u? Derivative of tan x is sec square x. So derivative of tan u is secant square u. Secant square u. So the final answer is dy by dx is equal to dy by du is nothing but secant square u into 2, or we can write dy by dx is equal to 2 into sec square. Instead of u I have to substitute 2x plus 3. Is it clear? Is it clear to everyone? So dy by dx is equal to 2 into sec square 2x plus 3. I have to replace that u. Don't forget to replace. Is it clear? This is nothing but a function of a function rule or chain rule. One more example. Okay. One more example. D by dx of sine of cos of x square. From the question itself, you can see that there are three functions over there. One is sine, cos, and algebraic functions x square. First, I am going to do this with respect to x square. So I am going to consider w is equal to x square. That means u v w. Okay. So w is equal to x square. What is dw by dx? Because in terms of x, so that I have to differentiate with respect to x. So dw by dx is something but 2x. Yes or no? No. I am going to consider this as w. So you will get cos w. Yes or no? That's what v. This cos w I am going to consider as v. So v is equal to cos w. I have to differentiate v with respect to w. That means dv by dw is minus sin w. Yes or no? Minus sin w. This implies that minus sin. What is w value? X square. Can I write like this? Minus sin x square. Yes or no? Similarly, this function is v is equal to cos w. Now, the entire function I am going to consider as y. That means y is equal to sin v. Y is equal to sin. This function is nothing but v. So y is equal to sin v. So y is equal to sin v. I have to differentiate this y with respect to v. That's why dy by dv is equal to derivative of sin is what? Cos v. So what is v over there? V is nothing but cos w. That means cos of. This cos is this one. Cos of. What is v value? V value is cos w. Instead of w, what is w value? X square. Yes or no? Mistake. Is it clear? So cos of, what is the value of v? Cos w. Instead of w, I will replace x square. So the answer is dy by dx is equal to dy by dv into dv by dw into dw by dx. If the functions are having three functions, that means three chains over here. Three pearls are there. Using that three pearl, we are making a chain. That is nothing but a chain. We are making the chain. That means we are making the differentiation with respect to three pearls. That is three pearls are sine, cos, and x square. So that is dy by dv into dv by dw into dw by dx. What is the answer? So dy by dx is equal to dy by dv. That is cos of cos x square into dv by dw is what? Minus sin x square into x into 2x. Is it clear? Is it clear to everyone? This is the way you have to do the function of a function rule or chain rule. So first you have to assume, first you have to check how many functions we have. If it is two functions, first formula dy by dx is equal to dy by du into du by dx. That is fine. If it is more than one or two, more than two, three functions, you have to consider like this: dy by dv into dv by dw into dw by dx. See, starting with the dy, ending with the dx. That's what we are finding dy by dx. So, in between parameters are our assumption, right? This v, w are our assumption. That's all. This is nothing but function of a function rule or chain rule. Very important topic, function of a function rule or chain rule. Is it clear? Go through this. Now, if you understand this, can you try this one? Try dy by dx. Find dy by dx if y is equal to cos of sine of x cube. Cos of sine of x cube. Try this. Next step is already done. Try this. So problems. Differentiate with respect to x. Sine of x square plus 5. Sine of cos x. Sec of tan of root x. Sine of ax plus b divided by cos of cx plus d. Using chain rule, we are going to prove. So, first question, sine of x square plus 5. Sine of x square plus 5. So, we have seen example, no? So, same concept. So, here I am going to consider x square plus 5. So, du by dx is nothing but 2x. du by dx is nothing but 2x. So, sine y is equal to sine u. Now, dy by du is nothing but derivative of sine u is what? Cos u. Now, dy by dx is dy by du into du by dx. Yes or no? So dy by du is what? Cos u into du by dx is what? 2x. Again, cos of what is u? X square plus 5 into 2x. This is the answer. Cos of x square plus 5 into 2x is the required answer for first one. Sin of x square plus 5. Is it clear? Now, second question. Second question. Sin of cos x. Sin of cos x. So here two functions we have. One is sin, another function is cos x. So u is equal to cos x I am going to consider. So du by dx, derivative of cos is minus sin x. So minus sin x. Now that is y is equal to sin of this function I am going to consider as u. Now dy by du, dy by du, derivative of sin is nothing but cos u. Yes or no? So therefore dy by dx is equal to dy by du into du by dx. See, for every question you have to write formula, then only you will by heart. Okay, so dy by dx is equal to dy by du into du by dx. You have dy by du, what is that? Cos u. So that is cos u into du by dx is what? Minus sin x. Again I have to replace this u. So cos of what is u? Cos x. Cos of cos x into minus sin x. Or you can write cos of cos x but cos square x. No? So you can write either stop over here or you can write cos square x into minus sin x. Okay. Second question. Is it clear? Go through this. We'll move on to the third question. Third and fourth is very important. Third question. Sec of tan of root x. Yes or no? So first I have to consider root x as the three functions are there. Yes or no? So w is equal to root x. We have seen the example, right? W is equal to root x. So dw by dx is nothing but 1 by 2 root x. Yes or no? This is nothing but dw by dx. Now, this one is what? V is equal to tan of w. Yes or no? Tan of w. What is dv by dw? Derivative of tan x is what? Derivative of tan x is sec square x. So sec square w. Sec square w. Yes or no? Sec square w. Now, again, this function is nothing but v. So y is equal to secant v. So dy by dv is nothing but what? Derivative of sec v is what? Derivative of sec square. Derivative of sec x is sec x tan. So sec v tan v. Yes or no? All the variables you have to replace your consideration. Yes or no? All this parameter v, w, you have to convert it into in terms of x format because the function in terms of x. That's why. So listen to me. dy by dx is equal to dy by dv into dv by dw into dw by dx. Yes or no? By dx. So what is dy by dx? dy by dx is equal to dy by dv. dy by dv is what? Sec v tan v. Sec v tan v. What is v? What is v over here? Tan w. Tan w. That means tan of what is w? 1 by 2 root x. Sorry, 1 by root x. Yes or no? Yes or no? So this one over sec v. What about tan v? Tan of 1 by root x. Yes or no? Tan of 1 by root x. Yes or no? This is something about dy by dv. Now dv by dw. dv by dw is what? Secant square w. In place of w, what I have to put? What I have to put? Root x. Yes or no? So 1 by root x. 1 by root x. Now dw by dx is what? 1 by 2 root x. This is the answer. Check. dy by dx is equal to dy by dv into dv by dw into dw by dx. That is sec into tan of 1 by root x plus tan into tan of 1 by root x plus sec square into 1 by root x, sec square 1 by root x into 1 by 2 root x. Is it clear? Let's go through this. And fourth question we have. So fourth question, differential perspective is sine of ax plus b divided by cos of cx plus b. Yes or no? Sine of ax plus b. Listen. Sine of ax plus b. Yes or no? Sine of ax plus b, I am going to consider u is equal to ax plus b. Now what is du by dx? Du by dx is nothing but a. Yes or no? Du by dx is nothing but a. So y is equal to sine u. Now dy by du is equal to derivative of sine u is cos u. So dy by dx is nothing but wait. Dy by dx is nothing but what? Dy by du, that is cos u. In place of u, I have to replace ax plus b into cos of ax plus b into du by dx nothing but a. This is nothing but first function of a derivative. Yes or no? First function of a derivative. This is a simple question having a quotient rule. That means we are going to use a quotient rule. Second function of derivative into first function minus first function into second function of derivative divided by second function the whole square. U by v rule. U by v rule. That is v dash u minus u dash v divided by v square. Or second function of derivative into first function minus first function of the derivative into second function, the whole thing divided by second function over square. So same concept we are going to use over here. So first function derivative we want, so we have find out the first function derivative. Now denominator derivative we want, we are going to find. So cos of cx plus b. What is cos of cx plus b? What is cos of cx plus b? Listen. Cos of cx plus b is equal to cos of cx plus b. So here also u is equal to cx plus b. Now du by dx is nothing but c. Yes or no? So cos u. Derivative of y is equal to cos u. dy by du is nothing but derivative of cos is nothing but minus sine. So minus sine u. In place of u I have to replace cx plus b. Therefore, dy by dx is equal to dy by du, that is minus sine. What is u over here? Cx plus d into c. This is second function or derivative. So you have derivative of this one, you have derivative of this one, so that you can apply the quotient rule. So that is quotient. I am going to apply the quotient rule. That is second function or derivative. What is second function or derivative? This is second function derivative. Minus sine cx plus d into c. Second function or derivative into first function, that is sine of ax plus b. Sine of ax plus b minus first function or derivative. First function or derivative is what? Cos of ax plus b. Cos of ax plus b into a. First function or derivative into second function. What is second function? Cos of cx plus b into cos of cx plus b, the whole thing divided by second function over a square. Second function square. So cos of cx plus b square. Yes. Is it clear? Very important question, third one and the fourth one. So first I have find out the differentiation of this one. Second I have to find the differentiation of this one. Now applying quotient rule. So applying quotient rule, QR, quotient rule, I have substituted over as per the formula. Is it clear to everyone? So this is nothing but a function of a function rule or chain rule. I hope you understand. Please do practice, then only you will understand the real concept of chain rule. It's very important upcoming topics. If you are not understanding this, it is very difficult to understand the upcoming topics. Okay, practice the problem, then only you will understand. If anyone did not subscribe my channel, please do subscribe and press the bell button. Thank you.